So in this video, I want to introduce you to the fourth kinematic equation that I didn't cover in the last video. I personally don't find this one to be that useful, so I usually keep it separate. You're welcome to use it, of course. It's available to you. But the other three you're going to, I think, discover to be your workhorses. But it's this. Delta x is equal to v initial plus v final over 2 times time. Sometimes written like this, v average time. You can probably see your way through to saying that if you take your endpoints, v initial, v final, add them together and divide it by 2, what that turns out to be is your v average. This is okay. Nothing wrong with this equation. I just don't particularly find it that useful. However, you have met this guy before, right? Delta x is a displacement. Let's assume though that let's assume that we're traveling in a straight line, so that the distance we travel is the same as the magnitude of the displacement, right? We talked about that. That's not necessarily the case. You could be going all over the place because all this cares about is final and initial positions. But let's assume for a second that we're not doing this. We're just going in a straight line, and that if I take the magnitude of this, that is throwing away directional information, that will be the same as the distance traveled. Then I can write this as distance. Well, v average, what is that? Well, usually we call that a rate of change, right? A rate of speed, sometimes people call that, although that's a little bit unclear to me. But let's just, for sake of argument, call it an r, and then we have our t. All right, you've seen this equation before. You used this in high school algebra, most likely. D is equal to RT. In fact, if I ask you, if you drive 80 miles an hour for 1 hour, how far do you go? You'd say 80 miles. You actually solved this equation, even though you didn't probably realize you were doing it. This is just an old friend, written in different language. Again, I don't particularly find it that useful, but it's there if you want it. All right.